The opinions expressed are those of the participants and do not necessarily reflect the official positions of the sponsors, advertisers, or presenters. Advertising does not imply endorsement by the sponsors and presenters.
Welcome back, everyone, to the Lighting Controls Podcast. I'm your host, Webster Marsh. My other host, Ron Kuzma, is out of town right now. He is at LDI, so I wish him the best, but we're going to continue on making some recordings and have some fun conversations. Today I have my guest, Steve Mesh, who, if you were watching the conversation series, you may have seen him on the show before, but now he's on the official Lighting Controls Podcast. Just to mention that that the Lighting Controls Podcast is presented by the Lighting Controls Association and is financially supported by the National Association of Innovative Lighting Distributors. And additionally, if you're listening to this on getagriponlighting.com, please check out lightingcontrolspodcast.com. Starting in the new year, you will only find our episodes on that website, not on Get a Grip. So please check it out, but also check it out because you can see industry news and check out some merch that we're selling as well, and any episodes that you haven't seen yet. All right, well, and now we're going to move over to Steve Mesh, who, if just for those who did not see the Conversation Series episode, if you could just give us a quick 1-2 on who you are and what you do.
I absolutely can. So good morning, everybody. I'm here in the middle of the Pacific Ocean in Honolulu. I started my career as a student at Parsons School of Design. And for those of you who are old enough to know, Jim Knuckles was the guy who started the entire Parsons lighting program. And in fact, he was my lighting instructor in my BFA program, where I studied architecture, interior design, urban design, product design, and so forth. But a lot of people actually right around that time went into lighting because of Jim Knuckles. You guys probably have heard of the Knuckles Fund, based, that's a memorial to Jim. And so he was one of the 13 founding members of the International Association of Lighting Designers. So that was sort of just coming into its own right around that time. So it tells you how old I am. I wasn't in the first generation of architectural lighting professionals. Maybe it was the second or possibly third. Now we're probably on the fifth, sixth, or seventh generation already. So I've been doing this for a very long time. And during the course of those 4+ decades, I've been mostly a lighting designer, but I've also done stints in other parts of the profession too. So I've actually worked for 3 legacy manufacturers, and also worked as the resident lighting expert at the Pacific Energy Center in San Francisco, run by Pacific Gas and Electric. So I've actually ended up seeing the industry from different viewpoints, which is pretty cool.
No, absolutely. And thank you for joining us, or joining me at least, again on this show, because, I think because of that rich experience and knowledge that you have, you really have a great opportunity to look at the landscape of the industry. And that's what I wanted to bring you in today to talk about, is really just, a lot of people get whiplash when they first enter our industry because of how many different people there are and what they do, and even the nuanced differences from one person to the next of the same job may be so different that you may not recognize them. So, I think it's interesting to hear that your first exposure to the lighting industry was as a student. I'm curious, when did you start thinking about lighting controls rather than just lighting?
Believe it or not, when I was in school as a student studying with Jim Knuckles.
So that's when you got your first... Go ahead.
Sorry. No, go ahead.
Oh, we've got a bit of a delay because he's out in Honolulu and I'm in Boston, so there may be some back and forth. But yeah, so I mean, you when you were a student studying lighting and architectural lighting design, presumably, you
Right.
also started studying lighting controls. Now, granted, at that time, what would you say the most prominent lighting control solution was for architecture?
So This is going back a long way. Wow, it's amazing. I've actually thought about this a couple of times recently. That's just purely coincidental, but it's amazing how long ago this was. At the time, so Jim, for those of you guys who didn't know Jim, and he's passed away a long time ago, he was just an amazing personality. That's why so many people went into the lighting field at that time. Jim was actually a theater student at Carnegie Mellon, and as you know, and probably a lot of the people who will be listening could imagine that if you came from the world of theater, because that used to be separated, right, theatrical and architectural, and that has since moved a little closer together and integrated to some degree. But at that point, that generation, his generation of lighting experts, really came mostly from the theater. And as you know, if you're watching a theatrical production, there's control all the time throughout the entire theatrical production on every single fixture in the theater, right? That didn't happen in architectural for a very, very long time. So the funny thing is that all those original people from the International Association of Lighting Designers, they embraced that stuff because it was natural for them, because they came from the theater. Jim was a huge proponent of controls, and it's interesting because I went to an art school, but I'm also pretty technical, so I really embraced that stuff. So, for example, I had BSR X10 controls for 10 years, in the 1980s in my apartments.
Just
carrier
to
current stuff.
for our listeners, they may not recognize what that means. Do you mind just giving a quick description of what that is?
Sure, that's carrier current. That's control where signals are sent through the power wires going through the zero cross point on the sine wave. And there are, systems commercially available that do that. It's not in huge prominence at this point, but BSR X10 was a sort of residential scaled version of it, where
so basically you would share the line voltage wiring for both line voltage and low voltage signal.
Right. So that was pretty wild stuff. It was futuristic at the point. But one of the things, Jim was probably the biggest proponent of occupancy sensors. So it's funny that at the time I think that was relatively new technology, but it was already established technology even when I entered the field. It just wasn't in such widespread use. So Jim, because he came from the world of theater and really embraced controls because it was so natural, he was a huge champion of controls everywhere. And at the time, that really mostly meant aux sensors. It doesn't mean that photo sensors for daylight harvesting were not available. It's just that aux sensors were the tried and true thing that absolutely worked. Daylighting is a whole complex subject.
And at that time,
but
aux sensors were not the same kind of aux sensor that we deal with today with a network lighting control system. It was a very different application.
Right. At the time, I don't even remember, to be honest, but I'm assuming if I could unlock those portions of my memory, I'm guessing that those were all standalone, where the aux sensors were actually on specific switch legs, controlling whatever was on the switch leg, right? Not network.
Right, so they would
not
upstream of the fixtures, and then they would open the circuit when there was vacancy, and then close the circuit when there was occupancy.
Right, and the funny thing is that now, all these years later, I ended up working for Pacific Gas and Electric as the resident lighting expert. But the whole reason that the energy centers in California exist is to teach people about energy efficiency, and aux sensors was such an easy way to do that. Right, it didn't involve the complexity of daylight harvesting, the differences between different photo sensors. It's just like, hey, you put in a PIR, passive infrared aux sensor, and it should turn the lights off, right? Theoretically. So
theoretically, yes. But
so that went back a long, long way. Yeah.
So in its infancy, at least to your exposure to lighting controls, there was a very small array of options in architecture. and it
Hmm.
was not really using control signal. It was literally just opening and closing the circuit just like a light switch. It had no communication protocols to belabor, and in fact,
Right.
dimming for the fixtures, 0 to 10 was just starting to come out for fluorescent dimming. But for the most
Right.
part, you would just actually switch off the lamps in the fixture. You would just go, okay,
Right. And
50%, shut off half the lamps.
right. I mean, fluorescent dimming ballasts have been around for longer than I've been in the industry. But having said that, tiny, tiny fraction of projects had fluorescent dimming on them just because it was enormously expensive. It wasn't ubiquitous like
Right.
0 to 10 volt dimming drivers for LEDs.
Sure.
Yeah. So there's something else that I embraced very early on, which was a very natural thing, which was architectural dimming systems. And
Mm.
it's funny, this is something else that I purely coincidentally just started thinking about the other day. It's been out of my mind for literally decades now. It's just unbelievable because now network lighting control is the big thing, right? At the time, the equivalent of that from that previous generation was architectural dimming systems where you would centralize loads in, and control them from dimming modules in panels, right? And,
Right.
in a way that was kind of analogous to network lighting controls, but it was not the same because there was no addressability. So it was
Right.
very
Right.
different.
So, I
But
mean,
but the purpose was dimming. The purpose specifically was dimming whatever the load was. Including lots of incandescent loads.
well, and to your point, that form factor of having a panel that has dimming capabilities really comes from theater. The
Mhm.
reason
Right.
theater, back in the bad old days would have racks upon racks upon racks of dimmers
Right.
that were to give that discrete control of all the fixtures that are aimed at the stage. And so to take that and apply
Right.
it to architectural settings, it's just that you need to cover more energy or you need to be dealing with a different voltage. But
Right.
the form factor was the same.
Right. And it's actually funny that you mentioned that because I never really thought about it in those terms. But when you think about it, the irony is that the real true theatrical systems actually had individual addressability, just like modern network lighting control systems do,
Right.
because you needed that to control every fixture in the theatrical setting
Yes.
exactly the way you wanted it. Then the funny thing is that once it migrated to architectural dimming systems, because it's not hard to dim incandescent lamps, right? And then they realized it wasn't that hard to control other kind of loads either. So the individual addressability went away because of the nature of what happens in architectural spaces. But the funny thing is now with architainment type spaces, they're like, hey, guess what? We have LED fixtures, we have network addressable lighting controls, and we can do all the same things we used to do in theatrical settings now.
Right.
It really came full circle. It's kind of funny.
It is, and it's almost like they kind of work on each other because sometimes an architectural
Right.
discovery will get incorporated into the
Hmm.
theatrical and vice
Sure.
versa. So, I mean, they're really
Hmm.
complementary. And like you said, we're seeing this kind of dovetailing of the two
Hmm.
over time as we, see the technologies really kind of solidify. I mean, DMX is becoming ubiquitous in architecture right
Hmm.
now. Um,
Oh, yeah.
and so being that DMX is pretty much the only protocol in theater, it's interesting to see that overlap now. But
Yeah.
so I mean, taking this perspective, I mean, you started in the industry as a student, and you were learning from probably the most prolific member of our industry at the time,
Mhm.
and maybe even going forward, it's arguable. But he instilled in you this idea of lighting controls. And I would say
Mhm.
that, when it comes to education in our industry right now, I guess the question is, do you think that that is still consistent? Are lighting controls being instilled in people the same way that, you know, you were getting?
That's a really good question, and to be really blunt, that's a hard thing to answer.
Sure.
Um, So the part of the issue with controls, and this is something that I've thought about since my days as the resident lighting expert at Pacific Gas and Electric at the Pacific Energy Center. That was from 2008 to 2011, so it's going back over 10 years now. What what I was confronted with there, because that was still that was for professionals, but it was still an educational facility, right, offering educational classes and so forth. It's so what I realized from that experience in particular is that it's so easy to get people to swap, take out old, let's say fluorescent troughers and put in a new LED trougher. That's so simple, and the water savings, it's a single number. It's very easy, right? So controls, one of the things about controls that, has always been an uphill battle, and it may be that that will never change. I've always liked to think it would change, but I'm not sure. Um, I used to have discussions with my PG&E colleagues who used to think like, hey, we've got to make this stuff easy for people. We have to package this, like swap the fixture and then have these controls, and then we have a single rebate number, to make it easy. And as I continued to teach more and more classes, especially in network lighting controls, I realized I didn't want to ever say that again. So now in classes, when I teach classes to professionals, I tell them that story and I say, you know what, guys? By definition, controls are complex, or systems are complex, and we can't do anything about it. That's just the definition, right? So you have choices. You could either cry about it, which you can, right, but it won't do anything, or you can accept that it's a little complex and that we can learn about it. It's nowhere near rocket science, not for any system I've ever dealt with in the lighting industry. So that's kind of an automatic uphill battle, and I don't know if I don't know what you think, because I know you've had plenty of experience with this too. But from my experience, it's just tough. It's a constant uphill battle. I enjoy fighting that uphill battle, and I found that teaching even introductory classes can get people from like zero to like maybe 40% of enthusiasm and general awareness. And it's like, wow, if you bring people from like 0 to 40, it's not that hard for them to chip away incrementally to get a lot more knowledge. But that initial hump to get from nothing to some reasonable
Right.
understanding of what these systems do, that's a big hump, right? In
Right.
schools, I
Right.
couldn't
No, no,
tell
no.
you
And
for schools, but yeah.
I I think you're right. And I mean, I think, when it comes to our industry and lighting designers specifically, there's still debate whether or not they should have an in-depth knowledge of how lighting control systems work and how to
Right,
understand the intricacies of it. So I guess
right.
there is a limit right now to what people are willing to tolerate when it comes to that. But at
Hmm.
the same time, I
Hmm.
think, if I were to ask every single person who considers themselves a lighting control specialist, I would be curious to hear when they entered the industry as a lighting control specialist. Because, for me, I started in theater, but it wasn't education that exposed me to lighting controls in the architectural setting. I mean, I understood DMX and theatrical lighting controls very well, but it was only when I realized that there was a lot of ambiguity and misinformation when it came to lighting controls. That's when I personally got attached to the idea of becoming a specialist. And I remember actually
Hmm.
having this conversation with my supervisor at the time, who, when I was working at an engineering firm, we had a small group of lighting designers in that firm. And I was one of them, and my supervisor was also one of them. And I said, how would you feel if I became a lighting control specialist? And she said, I would love that. I would like nothing more than to have a lighting control specialist, because of the fact that there's just so much out there that needs somebody to pay attention to the details and be ready to
Hmm.
provide that expertise. And so,
Yeah.
I'm curious where other people who are like us got sucked into the cogs of lighting controls in the architectural setting. And I imagine, there, for instance, integrators like Ron. I'm sure if Ron were here, he would have a good story about how, he started in theater, but the integration company that he works for is essentially a theatrical company, but they do architectural services as well because of the need.
Hmm.
And so
Yeah.
it's really kind of this organic process, but there's no like point of entry right now. There's no official point of entry. Unlike a lighting designer, you can go to these educational programs that are out there, like what you attended, and be prepared to be a lighting designer. But there's no formal track to becoming a lighting controls specialist.
Right. Yes, that's absolutely true. And it's funny for me to think about that statement, considering that I've been in this industry for over 40 years, because I was a student of and then ended up working for the guy who at the time was the biggest proponent of lighting controls for architectural spaces. It's kind of unbelievable when you think about it, but I just attribute that to the complexity. So there's a I guess you've kind of identified a gap, which, like, I've always known about, but I never put it into words the way you just did, and that was very eloquent. And what I would say, to support that, is that part of the problem that I'm trying to articulate is that controls are definitely more complex than just figuring out what an individual fixture type does. Like, if you show me a cut sheet of a wall washer, of a round, recessed wall washer, I know what it does. Or an accent light, or a down light, or an up light. I know what those things do. I know what the candle power curves look like. I know, how they're going to interreflect in the space. Controls is just automatically more complex. So that's one issue. The other issue is that although we're controlling lights with it, what we're really doing is we're controlling the electricity in order to control the lights. And we can't touch light, but we can see it. With electricity, we can't touch it or see it. Well, you could touch it, but only once. But you can't touch it or see it. So I think automatically there's a more mysterious aspect to electricity than for light. It's automatically more of a disconnect, right? But it's also used for a lot of different things, including lighting, but many other things. So one of the things that I did, it's going back 19 years now, to the first time I taught a class as an AIA registered provider in New York City. And I actually created an 8-hour class on electricity. So I marketed that to people from the AIA New York chapter. So these were all architects, right? I had 37 people show up on a Saturday. That was unbelievable. Wow. Because they wiped out their entire year's requirements of health, safety, welfare credits. It was amazing. They were in heaven. But I did a lot of really, really cool things. I worked with a friend of mine who's actually an electrical engineer, brilliant guy. Nice. And we did some amazing things all about electricity, including dealing with some dimmer stuff too. If I described it to you, you would be like, oh my God, I can't believe you did that. But we did things like, for example, at the time there was a company called Edmund Scientific, which it's really not the same thing anymore. They had these little plastic things that you could put a D-cell battery in, and then they gave you a couple of components that you could actually literally make an electric motor. And I bought those for people. They were $4.95. I bought them for people, and they made them in the class. And you know what? I had architects. I had people who were like principals at major New York City firms. They were completely engrossed in making an electric motor and then figuring out how to make it more efficient and spin quicker. That was unbelievable. And they learned a lot about electricity. They loved it. They were in heaven. So, the lighting thing, it's kind of funny. It's a little disconnect. It's a different animal.
Well, I think that's, it's really interesting. I want to go back to something you said, which is that you can't see or touch electricity, which I wonder if perhaps that's part of the issue, because a lot of people look at lighting controls as sort of a second step to lighting in itself. So you learn how to design light, and then you learn how to design lighting controls. But I would say that a lot of people who have affinity for lighting design don't overlap with the affinity for lighting controls design, because of the fact that lighting controls is all theoretical. There is very little that is actually testable without having a full-scale model, for instance, where you actually set up the wiring and do what you did in that class, where you have,
Yeah.
the components right in front of you. We can do like AGI or other light rendering tools to visualize lighting, but if you don't understand mentally how light works, that's only scratching the surface. But at the same time, a lot of lighting designers are visual people. A lot of lighting designers need that component for them to look at and see. And with lighting controls, there just isn't. There's nothing for them. And so I wonder if perhaps we're putting the cart before the horse by saying lighting controls comes after lighting.
Yeah, or at least that maybe they should happen concurrently, right? Why shouldn't they happen concurrently?
Sure.
There's no real reason, right? I mean, Jim Knuckles used to talk about controls all the time. He didn't say like, okay, well, this semester I'm gonna talk about the basics of light itself, and then next semester, if you make it that far, then we can get into controls. He didn't do that. He just, it was all, he loved talking about controls. He could talk about that all day long. So in so that is, yeah, it is absolutely a big difference. So the irony from a teaching perspective is that in order to show lighting effects for real, not simulated through AGI or something like that, the irony is that actually that's very expensive and very complicated, because if you think about any classroom that you've ever been in that's a really super duper classroom for lighting, they cost a lot of money, because you've got to have multiple fixtures of any one type in order to actually show the effect. Like, for example, wall washers, right? If you have recessed wall washers, okay, you can have just one, people will see the distribution, but the point is to see how multiples on the correct spacing will evenly light up the wall, because they're well-designed fixtures, right? That's a really big
And then
thing,
the
and that's just
flexibility
one.
to adjust that.
Yeah.
No, and the
Right.
ability to adjust those fixtures so that you can see what happens when you don't have the appropriate spacing.
Right, absolutely. I mean, it's just,
That's
I
also
mean, to do that in for real, right, with real stuff, is a really complex. That's why any room that you've ever been in that's a super duper lighting classroom is, the one at the Pacific Energy Center cost $250,000.
Right.
It's just for one room.
It's,
I mean, it was just an enormously complicated thing. So
and so
the
now
irony
when
is
you
that
add
with,
in the lighting controls component, you multiply that.
oh, yeah, well, right. So the funny thing is that when I was at the Pacific Energy Center, my colleague Rick Miller and I used to do these hands-on classes for controls before it was sort of slightly before the era of network lighting controls. I mean, network lighting controls existed, but wasn't really that big of a deal. Nobody incentivized them at that point. So what we would do is we would actually just do basics. So we would do classes where we had 6 tables, and people would come in for the day, and they would rotate through these 6 tables. So I don't know if I can remember all of them, but I think one of them was probably wall box controls like dimmers, aux sensors, that was number 2, photo sensors for daylight harvesting, that was 3, low voltage relay panels. I know Rick had some dolly stuff because he's one of the country's foremost dolly experts. That's 5. I know there was another, I forgot what it was. Anyway, we had those different types of things, but those were kind of pre-NLC, pre-network lighting controls, right? Now, I have to spend a whole day just focusing on network lighting controls, but the idea is that I've always done this hands-on stuff, and the irony is it's actually pretty easy to do with controls, as you know, because I can take the controls that I need to teach a network lighting controls class. I can literally put them in my suitcase with my clothes. It's not, they're really small. They're just tiny.
The fundamental components, that the actual devices themselves are small and easy to interconnect, but it's the theoretical, the stuff that you need to know to make sure that those interconnections are going to do what you need them to do, and even further, maybe even the understanding of the software itself that allows you to program that stuff. That's the heavy lift there.
Right, that's complexity, right? And when I teach classes now, which I do on behalf of DLC, but also other utilities and other organizations, one of the things that I really hammer on all the time is how, people, as you could imagine, you could say, oh, okay, well, let's see, I'm doing the lighting for such and such project. Well, I Okay, I've figured out all the fixtures. I know what the lighting effects are going to be. Well, now what? Well, I have to have controls because there are code requirements for them, or whatever
Right.
the motivating factor is. Um, so easy thing would be to say, okay, I'm going to look at some manufacturers' websites. Maybe I'll look at some uh, uh, conglomerates' websites. I'll look at some small independent stuff. But I can kind of see from what I'm looking at, or I have some binder. I don't know if anybody has binders anymore, but if you had like a binder, somebody's binder, like, oh, such and such controls. Let's see. Okay, well, yeah, I need a server. So here's the server. I'll need the um, the wall-mounted interfaces, the switches. I'll need the aux sensors. I'll need the photo sensors. That doesn't tell you anything whatsoever about how the system actually works.
Right.
So what I hammer on that all the time, that if you really don't want to be surprised on a project, you better spend some time working with the actual system. And that means probably contacting a rep and saying, I need to see a working demo of this. I try to do, I've done that in classes. I've even pulled up software for systems that I've um, proposed on projects that I even still have remote access to, because if you don't see the software, you don't know what it's doing, right? There,
But I
there
mean,
are
I
things
guess
in the software that make a big difference in terms of functionality.
absolutely, absolutely, and going back to when you said reaching out to a sales rep, I guess that is really another exposure point for people new to the industry to be able to get an
Hmm.
understanding of lighting controls, is to just
Hmm.
communicate with a sales rep. So somebody who
Right, sure.
for anybody who's listening who doesn't understand what a sales rep is, it is a person who represents a manufacturer, and their job is to sell their product and get it onto
Hmm.
projects and to work with specifiers to facilitate that. I mean, it's not any different than like a car salesman, but when it comes to lighting controls, because of those nuances with software or hardware, really anything, the difference, between manufacturer X and manufacturer Y could be really varied. There could be
Could be
so
big,
many
yeah.
differences that, if you specify a system and you have very specific needs, and somebody comes in and says, hey, I want to be an equal for that, which means, take me instead of the group that you specified to do this project. Vetting that equal can sometimes be just a headache because of how different the
Yeah,
systems are, and you can't just one-to-one
right.
replace the components. And
No, it's
so
very complex.
new people to the industry, I think, have also a heavy lift because it's not just one sales rep. It's tons of sales reps you should be talking to and getting an understanding of all the varieties of the brands that they have, not just brand X, but brand X, sub brand Y, you know,
Hmm.
class 2. There's so many different varieties within the lighting controls um, rainbow, I guess is the term that I would use. But you know, to be able to contact a sales rep and get them into your office and to give you genuine and honest answers can be challenging, just because of
Yeah,
how much time you have to dedicate to that. And when it
right,
comes to like a design firm, are they going to pay for hours and hours of study of all the different brands out there?
right. So that's, it's very interesting that you're bringing that up, because what, you're identifying a lot of, problem. I hate to use this term, but they're really problem areas in the
Sure.
process of, you know, this becoming easier for people in our industry. I mean, you and I, we live and breathe this all the time. So, and even for me, it's hard to keep up with it. I'm sure it is for you, right? It's like, wow,
Oh,
what is it
sure.
like for people who aren't focusing all their attention? Must be incredible, right? They must
Yeah,
need
for
even
sure.
more alcohol than I need. It's incredible. So it's funny. One of the things that I just thought about as you were discussing all that is some classes that we've been doing in San Francisco on behalf of Pacific Gas and Electric. So they're still asking me to do work with them, even though I'm no longer the official resident expert there. But one of the things that we've been doing since pre-pandemic is actually what we call manufacturers demo classes. So the
Hmm.
so the I should actually back up for a minute, because you'd probably you may or may not know this, but it's kind of interesting history. Do you want to take a guess what the per capita change in electrical consumption has been in California for the last 40 years?
For
Per
the last
capita
40 years.
change? Last 40 years? Just want to take a wild guess.
This is either going to be really high or really low, and I'm guessing that it's a
Right.
low number, a surprisingly low number.
You are correct. So, so the per capita change in California per capita in electrical consumption,
Yeah,
dead flat,
0. So that
zero.
actually meets up with a term that I've heard called Jevons paradox, which means that as efficiency goes up, consumption stays the same because people find ways to eat up that reduction.
Of course. Well, people also have a lot more devices that require electricity now than they had 40 years ago. But
well, and
so
now as
so
electric car charging is coming out, we're also
right,
seeing that explode too.
Right.
But
of
anyways,
course.
continue.
But to make up for that, of course, everybody's going to have dimmed LED lamps in their houses, I'm sure. That's my dream. Anyway, so the per capita change in California. Let's see if I can do this with my arm. Okay, so dead flat, right? Europe has been going like this. They've been coming up like this, and they're close to meeting the California levels. They may have even exceeded it by now. But the rest of the country, of the U.S., like this. So from 40 years ago, they're way higher than California. I'm not saying that to be California-centric just because I lived there for 14 years. What California did a long time ago is they said, we know we're going to have a problem. We're already the most populous state. We're going to have a problem with our grid. Let's start doing things now to reduce consumption on the grid. And one of the things that they did is they mandated these energy centers. That wasn't done anywhere else. I mean, there are some of these kinds of things in other places now, but that doesn't really exist in most places. It's mandated by law in California, which is why there's 9 of them that the IOUs run, and some others too. So it turns out that those are actually extremely effective in teaching people, which are all mostly professionals. I mean, school groups do come in. It's actually a really good thing for school groups to do that. And if school groups can go to any major manufacturer's educational facility, that's great too, right? If they're willing to have school groups come in, hey, great, right? It's great exposure to stuff. They're not going to see that in a school environment, right?
And I'm getting an inkling that we did touch on this in the conversation series episode now, that
I'm sure,
there's evidence that this kind of education initiative has paid off in dividends.
Yeah. Mm-hmm. Yeah, there absolutely is. There's an opinion dynamics study that shows that the Pacific Energy Center actually accounted for twice what their annual budget was, which shows you how effective it was. Or you could say they were underfunded, one or the other. Anyway, yes.
I mean, if you're contrasting the other states, they were effectively funded, whereas the rest of the states are underfunded.
Yeah. So I should also back up and tell you about something kind of related. So I mentioned that in 2003, which is almost 20 years ago now, I actually became an AIA registered provider so that I could do this kind of thing for practicing professionals, because from a marketing viewpoint, it was easy because those guys need to get credits. That was the driver for me to do that. The reason that I got into that, though, which you'll be curious to hear about, is because IES New York section put on a 4-hour, I think it was a 4-hour class on a Saturday for people about electricity. And it was run by some members who happened to work for electrical engineering companies. They did a great job, and 91 people showed up. So imagine 91 people showing up on a Saturday, right, to take half of their Saturday to learn about electricity. So yeah, some people probably needed credits for their LC, but people really wanted to learn about something that many of them knew virtually nothing about,
Right.
it's historically, I don't have to tell you, you know, but maybe other people don't. The irony with lighting designers is that you can become a lighting designer and really know virtually nothing about electricity, and you could probably spend your entire career as a really big deal lighting designer knowing virtually nothing. And there are reasons for that, one of which is because lighting designers aren't the legal entity responsible for signing off on, wiring methods and life
Right.
safety, like emergency lighting. And, everybody's always like, nope, I'm not the engineer. I don't do that, right? So that's
Yep.
understandable, right? Of course, I'm not a licensed engineer. I don't want to do anything that's going to suggest that I'm going to assume liability for something that I'm not licensed to assume liability for. But what I tell people who come to classes, and it could be all kinds of different people, for 20 years it was people in New York area design schools, and then since then it's been all sorts of practicing professionals, just all sorts of different roles. And what I always tell people is why, even if you're not the party who's legally responsible for the, power drawings or, distribution, what have you, why wouldn't you want to know about it? Because let's say you're a lighting designer and you're not a licensed engineer, right? Like me. I'm a lighting designer. I'm not a licensed engineer. Because I know a fair amount about the electrical stuff, it just means that I'm in a position to be able to interface people and seem like I have a fair amount of authority because I know what I'm talking about. It also means that, an owner, for example, or an architect can say, hey, we know that you're not the person who's going to stamp the drawings, that the, inspector's going to look at, but we trust you to oversee this part of the process. You may not deal with every single detail of the electrical. We know that's not your, legally your legal responsibility. But yeah, you seem to understand like what dimming systems do and how we're going to interface and, and so forth. And I'm like, yeah, I do because I live and breathe it.
Right.
Sure, I could tell you some very interesting stories about that. I can tell you.
No, I know exactly what you're talking about, and in fact, I have this potent memory of a phone conversation I had with somebody who, basically I was talking about electricity, and I can't remember exactly what it was that we were talking about, but at one point the person stopped me and said, "You sound like you know what you're talking about. Why is that?"
Well, that's because you play one on TV. That's why, right? If you can
But
play somebody who knows about electricity on TV, then they're going to trust you, right?
right,
But it's because you
right,
know, right? You may not be a
right.
licensed
Well, and
electrical engineer, but you really know. I would trust you any day.
well, thank you. I appreciate that. But I mean, I think, I attribute that to my origins in the industry with the engineering firm. I mean, I learned a ton of stuff working in an engineering firm that is peripherally important
Hmm.
to what I do, but it still is critical when it comes down to these intricacies of a lighting control system.
Hmm.
Maybe okay, maybe I don't really need to know the nuanced differences of 120 volt versus 270 volt and how it's wired and what the amperage ratings of everything is. But at the same time, I need to understand, at least from a theoretical standpoint, what that's referring to.
Yeah.
Okay, why
Hmm.
can't I connect my 120 volt fixture to a 277 volt power line?
Sure.
Theoretically, it should work, right? No. And here's why.
Right.
So,
Well,
there's a lot
maybe
of
for a brief millisecond. Right.
you'll let the smoke out of the box.
Right. Right.
But um, you know, I think that kind of information from lighting designers who don't work with engineers directly, who are either part of just lighting design firms that are isolated, or just because they take that hard stance of like, I am not stamping drawings and therefore I shouldn't be
Right.
responsible for this
Right.
information. They just over time learn that information, but there's no formal track that says this is information that's important, whether you believe it's important or not.
Right.
And so, I think it just hammers on to that point of, okay, how does anybody learn this important information outside of just an emergent situation of like, oh, I didn't know you couldn't connect 120 volt
Right.
exclusive fixtures to 277
Right.
volt. Well, Oops. Okay. Guess we got to replace
And
all
that's
those
pretty basic,
fixtures.
right? Yeah,
Yeah.
yeah, and that's
Well,
that's pretty basic, right? Yeah, but sure,
it's
no,
a
people
basic
don't know that.
example, but I think there's plenty of other scenarios that fall along those lines of just not understanding the differences of certain things that engineers would otherwise be ensuring compatibility.
Sure.
But if you're a lighting designer, you're still giving guidance. You're still saying this is the light fixture I want. And if the engineer is doing their job and saying, well, this is the voltage that I have, or this is the
Hmm.
equipment that I have, you know, the lighting designer should at least go, I need I need a different thing, or please make sure that this is going to work because that's what I need. I need these lights.
Yeah, of course, of course. I have an interesting story that I may have told part or all of the story when the last interview that we did. I worked as a consultant to Lawrence Berkeley National Labs on a research project in 2015. It actually happened over a period of 5 years, but 2015 is when they actually installed the equipment in a big giant headquarters building in New York City. And it's kind of in the public domain. I don't need to mention the name of the company, but it's a big company right across from the Freedom Tower. And they let us recommend four different network lighting control systems, one per quadrant of a particular floor of the building. And this was sort of like the retrofit equivalent to the New York Times project that happened about 10 years earlier. So the New York Times was a new building in Times Square, and they found out that by using a network lighting control systems and doing pretty good job setting variables, that they saved 38% of the max connected load from the outset. So they were like, wow, that's, boy, I don't know what the
Crazy.
payback was, but it might have been like a week. Like 38% is a
Right.
huge number, right?
Well,
10
yeah, I
years
mean, we're not
later,
talking LED
DOE's,
loads right now.
right, no, no, no,
Right.
no, that was high, that was T5 fluorescent. So
Right.
now, yeah, but that was the prevailing technology, right? So now,
Right.
10 years later, they said, okay, well, boy, we should do the same thing, but we should do that for retrofit because think about all the existing building stock, right?
Mhm.
So it was really kind of like a demonstration project. It wasn't really predominantly to collect hard data on savings and so forth. It saved plenty of energy, believe me. But
Mhm.
I was actually on site for 18 nights of the original installation, not for all of it, but for the first 18 nights of it. And I was really I was supposed to be there just to observe. And there were four electricians from a company in Brooklyn. I had to get my Brooklyn to English dictionary out to translate, but it was fine. Everything worked out great, and they were very, these were very skilled electricians. You could imagine these guys knew plenty, right? They were very, very experienced guys, and this was a major New York financial company, right? So they actually had a New York City lighting designer that had some involvement on the project because that was sort of their go-to New York City lighting designer. They had an electrical engineer because hey, they were affecting things like emergency lighting. They had to have somebody stamp the drawings, right? So they still had all of those people involved, but they weren't involved the same way that they would be on a new project where everybody has
Mm.
meetings, for weeks and months and years on end before they ever, put the first shovel into the ground. This is really
Right.
different. And what I saw was really interesting. And I'll give you the quick summary. And I almost hesitate to say this, but almost everything that could have gone wrong went wrong. So I kind of
Of
hesitate to
course.
say that because it makes it sound like, oh boy, I should never deal with this kind of complex stuff. But the unbelievable thing is that not a single thing that happened that went wrong was avoidable. Every single thing was
Mm.
easily avoidable if they had had some initial discussion and education by
Mm.
whomever. It could have been the vendors, it could have been sales reps, it could have been lighting, experts like me. And in fact, I actually kind of played that role inadvertently because I kind of had to. For 10 minutes, literally the first night for 10 minutes, these guys were looking at some components that I think if they had to install them normally, they probably would have been fine. But it turns out they had to remote them in the plenum, and one was a wired controller, and the other was wireless, because that's how you dealt with the emergency at the time. There was no better solution for emergency lighting. So it was a slightly atypical condition, and these guys weren't used to that kind of thing anyway, because it's new to them. This was, like 10 years ago, right?
Right.
It's funny because I asked them if they had ever installed a particular system, which I won't mention the name, but you would know, very popular system that's been around for a long time. And they're like, yeah. And I said, well, guess what? Then you've installed the Dolly system, because it's effectively Dolly. And people are like this with Dolly. So it's like, wow, you guys have already installed a Dolly system. And, but hey, this was a different thing. And because they weren't given job specific info and so forth, and, they're it's just unbelievable, the stuff that I saw. And it was almost comic. And it was an awkward position for me to be in. And I said to them, guys, I'm not doing this to make you look stupid. The whole point of me being here is to see how easily you can install this stuff, right? So that's electricians, right? But imagine that there's electrical engineers, and there are issues on the electrical engineering side. And, then there was issues like IT issues. I'm sure you could imagine, like, they wanted to have the access to the servers on a floor 10 floors below. They didn't have any infrastructure to get that signal down, and they're like, oh, okay, well, how are we going to do that? We're going to install new fiber, and oh my God, like, that's IT side, and lighting designers don't deal with IT people, right? But guess what? They do now, right? But so it's a different,
but I think
it's a different world.
I think this is another exposure point for people in our industry, which is what I'm going to call the oops factor, where something goes wrong that makes you learn from that mistake, and that's how you become a control specialist, because you found the solution to the problem. And then suddenly it just kind of snowballs from there. Well, so and so fixed the problem on this project, so maybe they can fix it on that project, and
right.
That's another thing that happened with me. It was like I would get pulled into these odd projects that were just going haywire with lighting controls, and I'd look at it and I go, well, there's your problem, and fix it. And they'd be like, okay, just throw them on whatever projects have problems. So I think there's a lot of that in our industry too, which is, I would say, not great, because there's a problem to begin with. It's great that there are problem solvers out there that are willing to do the knee-deep digging of information and detective work required to really solve the problem of a lighting control system that's just not working. But at the same time, we really want to get away from that. We're at a point where we really have the expertise in the industry to be tapped into, but for some reason it's just not being utilized in a way to avoid these issues.
I think, based on my experience, which is mostly with education at this point, what I have seen, because I've pushed it a lot in classes that I've done for years now, with having people wire up real stuff and really make it work and see what it does. And every single time something happens, you can imagine, like, these are systems, right? Things happen. And most people would be like, oh my God, I don't want to do a hands-on thing in a class, because what if something doesn't work right? And I'm like, well, then we'll find out, And I've never had something happen in a class that we couldn't figure out, and that's a great message, right? But I'll tell you, I think that I could characterize those things in different levels or different ranges of complexity. So I can tell you that there are some things that, well, first of all, there are things that I'm not an expert in. Like, I would probably say, geez, I got to call Webster Marsh, if I want to dig into a DMX is a perfect example. I've never worked with a DMX system. I don't know anything about it. I'm sure it's not rocket science. I'm sure I could learn it. I can fly a plane. Believe me, I can learn about DMX, but I'd have to learn it, right? So I know literally nothing about it. So for me, that's like a giant task, right? But what I have found in the work that I've done in these classes is that there are some general things that you can easily glean from working with, one or more things on a hands-on basis, which means you have to have the actual equipment, right? I'll give you an example of something, and you could think of where you think it falls in terms of the first third, the second third, the most complicated
Sure.
third. I started working with the Bluetooth system in classes, in hands-on classes that I'm doing in Illinois. And this company actually makes integral LLLC type sensors, which means they make an integral PIR aux sensor that has a photodiode in it, so you can do daylight harvesting and aux sensing. That's great. It turns out that even though these are all individually addressable, because you have to get on the DLC qualified products list, it turns out that you can't really use this as an LLLC system, because in order to do that, literally every single fixture would have to be its own zone. And nobody would ever set up the system that way. So you can do it, but nobody would ever do that. It's crazy, right? You want to have a zone, and then say, okay, within the zone, all those fixtures operate independently based on their integral sensors, right? Hey, I do this for a living, and it's not until I had the equipment in the classes, and then I found out, whoa, you can't really use this effectively, in practice as an LLLC system. And these classes are specifically focused on LLLC. So I'm like, oh, I better not get into that in the class, But I wouldn't have known that if I didn't have the equipment.
Sure. No, I think that right there is a great identifier of the disparation between energy code requirements and practical application, because energy code came out with LLLC as a way of saying, okay, we can make this the most efficient possible by having the lighting following the person. But at the same time, the reality of the situation is people don't like it when a light follows them. The space just doesn't feel comfortable, and so nobody wants to be in that space. So the practical application really is more of using LLLC as a way of detection. But at the same time, then why do you need a sensor in each single fixture? And I mean, I'm not going to debate the whether LLLC is good or bad, because I think there's no bad solution when it comes to lighting controls. There's just, why are you doing it? And so why are you doing LLLC? I think there's a lot of great IoT applications for LLLC. I think there's, if you're really trying to squeeze as much as you can out of every single fixture, fine. LLLC is a great option too. But is it going to be what everybody wants, everybody uses every single day? No, of course not. But I think you're right. Unless you get somebody sitting there looking at it and experiencing it, they're just going to have it in their head like, oh, yeah, this is the perfect solution. This works. Why would anybody want anything else? And I know engineers who will do LLLC specifications because they don't have answers, and they go, well, we'll just zone everything independently, and that way we have our butts covered if the owner comes back and says, well, I want this to be controlled that way differently.
Right. But of course we could debate the pros and cons of LLLC. We could be like gladiators in the Colosseum duking it out about that subject. But I try. Of course, I have opinions about these things, but I really try very hard to appear to be agnostic about that when I'm teaching about it, because it's not the reason that I'd rather explain. I'd rather take the energy to explain stuff so that people understand it, because they're going to make their own judgments anyway, based on whatever their needs are. But what I do want them to take away, because we've procured this equipment and we brought it to the class locations, for something like that, if I hadn't worked with the system, I would not have figured that out, because it's not something the vendor told me. And this is a really great vendor, but it's a nuance of how the software works that it has to do with zoning. And zoning is something that, is one of these things where it's like, okay, zoning is a little complicated. We could have normal zoning. Some systems have nested zoning. Some systems only have nested zoning for photosensors for a particular reason. That's a whole thing. Like, people are like, oh, I don't need to hear about that. It's like, yeah, no, you do, because if you wanted to do a particular thing and the software doesn't let you do it, then you just wasted your money. So that's my point. My point is that, and I don't really know if there's a really easy way to explain that stuff other than having hands-on classes with this. So one of the things that we're doing in San Francisco, that I'm doing remotely, fortunately, from Honolulu, is we're continuing to do these manufacturers demo classes. And because we couldn't do them in person during the lockdown, we started creating videos. I actually did the first one as a template, and then other vendors have actually continued to do this. So the whole idea of that is to maybe eventually have a library of like videos, not stuff that you would see from a vendor. And some of them are like, oh, we have videos already on YouTube. It's like, yeah, no, that's not what that's great stuff for what
Right.
it is, but that's
Let's
marketing,
watch the
right?
great graphics of the logo
Right.
orbiting and
No,
the
some of them are really good. I'll
right.
give you a great example. One of them is a thing about automated testing and reporting for EM ballasts and exit signs. That there's a really great 1-minute video about that. I learned a lot of stuff from that. But otherwise, no, we need like a longer thing that has a particular format. It shows the components, it shows the software in use. It's very particular about that. I'm like, no, these are the things I want you to show, and they've done it, and they're great. Hopefully that'll
Well, and I
fill a
think,
little bit of a gap.
no, I agree. And we're almost out of time here, so I just want to give a quick breakdown of the things that we've talked about. I mean, I think we had a really interesting journey today, but the focus that I was trying to pull here was about exposure points, and I think we really hit on that quite well because when it comes to our industry, when it comes to lighting controls specialists, people who understand lighting controls more than the average lighting designer, there's no real formal track. And I think that sort of
None.
application where there's videos that are agnostic, not by the manufacturer, but by just some independent person talking about how lighting controls function and what the theoretical components behind lighting controls are, what people need to think about when it comes to designing a lighting control system. There's nothing out there right now that really helps people
Yeah,
narrow in. I know Lighting Controls
right,
Association has the Education Express, which is great, but
right.
that's not a Parsons class or
Yeah,
program.
yeah,
That is
right,
just, you need to know where to look to get it. You can't
right,
just, go, I'm going to become a lighting control specialist. I'm going to follow this track. No, you need to basically have an emergent circumstance that causes you to
yeah,
go, oh, lighting controls, interesting.
yeah.
So,
Yeah,
I
there's
think,
room for that in the industry for sure. I've tried to attack it, a lot of different ways, but it's tricky. That's been my dilemma and my quest for a lot of years now is who wants to really do that and take that on. The CALCTP thing was sort of a major attempt at that. That was the California Advanced Lighting Controls Training Program. Got an award
right.
for the worst acronym of the year. But but anyway, that was the whole idea of that program, right? Is to say, hey, we need to train at least installing electrical contractors to some, basic level to make sure that they're, putting these things in right and doing some basic commissioning. And I'm not really sure where they stand with that. And there was a hope that that would become a national program, but it's, I don't know if that's going anywhere. It took years for them
Right.
just to address NLCs, for example. So now it's like, hey, yeah, you got to deal with NLCs here. So
Right.
yeah,
Well,
there's
and
there's
I mean,
there's
hopefully we'll see more adoption or more, official programs out there to help people
hope so.
get more familiar with lighting controls. But I think, there's so many other challenges in our industry surrounding lighting controls that may be precluding our advancement with these initiatives. But maybe we'll see some changes in the next few years, and that would be awesome. I would be
Yeah,
100% behind that, and I think a lot of people like us would.
it
But
just the one last thing I'll say about this is that
yeah.
it's the only really growth area that's been identified by consultants
Mm.
about what the potential is in the market for, like, let's say utilities making major gains on energy reduction, because like we've squeezed everything else to death. So what's left? Well,
Right.
this is one thing that's left, and because there's no formal, educational program or a certification program or what have you, it's kind of ripe for that. That's what all these things we're trying to do, like CALCTP. But it's like, guys, somebody's got to get the lead out here. I'm not the person to spearhead that, but I know how to do it. You do too. But The question is who's going to fund that, which would acknowledge that that's something that could really move the needle very significantly in the market. I'm not sure what else is going to move the needle in the lighting industry at this point, the way lighting controls could.
Sure.
I'm sure you agree.
No, I agree.
Right?
Yeah,
So
absolutely.
that's the question, right? Is how's that going to really happen moving forward? I don't have enough money in my personal savings account to fund it. I'm sorry. I wish I did, but I don't. So.
I wish I did too.
Yes,
but yeah,
me.
I mean, I think you're absolutely right, and hopefully somebody with deeper pockets is going to look at this and see a real opportunity to market off of it, because people are starving for this.
They are. I know it from people who come to the classes. They're like, "Oh, this is the organization, by the way, that's supporting this, the NAILD, had me come and give a talk at their conference in San Antonio 5 years ago, and I just gave a kind of basic 1 hour talk on NLCs. You could have done the same thing, and somebody came up to me afterwards and said, "Can I follow you around for 6 months?" So of course I was very flattered. I thought, wow, you want to get the glare from my head into your eyes for 6 months? Wow. But it's because he was starved for more detailed information about NLCs than he was getting through whatever other sources. So that's how I know for sure that there's a need for this. Yeah, it's not just you and I saying it. I hear it from people. So.
No, great data to back that up. But
Yes.
Steve, thank you so much for joining me today on this unique one-on-one session, and I think hopefully our listeners got a lot out of this, and maybe somebody who with deeper pockets is listening.
Hope so.
But thanks so much, Steve.
Well, it's my pleasure. Thank you. And this may be a little in advance, but Mele Kaliki Maka.
Well, what a great conversation, Steve. Just to mention that this podcast is presented by the Lighting Controls Association and is financially supported by the National Association of Innovative Lighting Distributors. Also, if you're listening to this on getagriponlighting.com, please check out lightingcontrolspodcast.com, where you can check out other episodes, industry news, and maybe even purchase some merch for the podcast. But thank you so much, and thank you, Steve, for joining me today.